Hello everyone, I am Geeta, Assistant Professor, Department of Mathematics, SNS College of Technology. Our students from CSE IoT Department.
I am Yashoda.
I am Harini.
I am Ram Shakti. I am Ashmita.
I am Sudhar.
Dear all, in this session we are going to discuss about design thinking based group discussion on control charts. Okay, which is under the statistical quality control. Okay, so first we define empathy part. So, if you want to enter into the control chart means you should know what are the applications of in your area. That is the empathy part now. Okay.
So first of all, the application of control chart is statistical tool. It is used to control progress and improve the limits values, and it mainly used in the sensor data monitoring. So sensor data monitoring is used for correct the environmental data such as humidity, temperature, pressures, and intensity of lights. So it monitors data and remains its data in the limits values. Then, for example, in the agriculture system, the temperature monitor value we can use the crop condition. If the temperature goes behind the crop limit values, so it gives the alert and excuse the farmer to under control the farmer systems, and according to that we can control the farmer systems.
So I am explaining about one of the application in C chart in IoT. This fault detection and prediction. Control charts are widely used in IoT applications to detect abnormal behaviors to device and continuously monitoring their performance. Is when the observed values cross the normal limits, it indicates that system may not be operating properly. This helps may not be operating properly. This helps engineers identify the faults at an early stage and be corrective actions before a system fault. An example, in an industrial IoT setup, vibration sensors are attached to machines. Normally, vibration levels stay within a specific range. If the vibration count suddenly highs, the machine alerts the engineer to inspect the machines before it falls.
I am going to talk about network performance monitoring. IoT system rely heavy on network communication between devices. Control chart can be used to monitor network parameters such as latency, packet loss, and bandwidth usage. If there is a sudden increase in delay or data loss, the control chart identifies it as abnormal conditions, and this helps engineers troubleshoot network issue and maintain reliable communication.
So now I am going to talk about healthcare IoT application. In healthcare, IoT devices like smartwatches and sensors are used to monitor patient health. These devices measures like heart rate, body temperature, and blood pressure. The data controlled from the devices is checked using control chart. Control chart helps us to understand whether the value are normal or not. For example, if a patient heart rate is suddenly becomes high, the control chart will detect it and use an alert. So doctors can take immediate action. Overall, the system helps in early detection of problems, quick treatment, and better patient care.
So I am going to talk about the energy consumption using a control chart. In modern smart home and smart grids, the electricity are monitored by using IoT devices. These IoT devices are controlled by using and collects the real-time data from applications like fan and air refrigerators and something else. And to analyze this data, we use a control chart. By using this control chart, we can help us to understand whether the energy flow is normal or abnormal. There is a sudden increase or spike in usage. The control chart quickly detects and do whatever necessary things. In conclusions, the control chart play a vital role in model optimization using a power usage. Thank you.
So that's why we define control charts. In control chart, we are having two types. One is variable chart, another one is attributes. Under variables are what are the variable chart? Can you tell me?
So we have the mean chart,
Mean chart, range chart. Okay. What are all the attributes chart?
P chart.
P chart, NP chart, C chart. Okay. So this is our defined part. In our ideate part, we calculate the central limit, LCL limit, and UCL limit based on the chart type. So after that, we plot the given data into the graph, and if the given data lies under the LCL and the UCL limits, means the process is under the control. Otherwise, the process is not under the control. Okay. Thank you all. Thank you for your good cooperation.